All right, moving on to chapter 9. In chapter 9, you guys, we're going to get into conics. Conics is derived from the word cone, things relating to cones. Everything that we're doing in the conic section is somewhat related to that. But we're going to get into parabolas, circles, ellipsi, those fun things. So that's all coming up. We need to review two important formulas before that, though. So 9.1 is all about review. So I'm going to teach this here ahead of time by video. So we're looking at midpoint and distance formulas. Okay, so I'm going to review those with you guys. Remember that a midpoint formula is simply the halfway point between 2 points. So what we can do is, if we know two coordinates, to find the midpoint, all we do is we add the x's together and divide by 2, and then we add the y's together and divide by 2 to get us an average. Okay, so this is our midpoint formula that we have here. x1 plus x2 over 2, comma y1 plus y2 over 2. So let me do a quick example with you guys on that. Example 1. I guess I have two examples here. So example 1, a and b. Find the coordinate of the midpoint of line AB if you have these 2 points as a and b, 5, 12, and negative 4, 8. So again, I'm just going to take my two x's and add them together. Okay, so that's 5 minus 4, because it's 5 plus minus 4, which is just 5 minus 4, divided by 2, which equals 1/2. Okay, so that's my first coordinate. My other one would be 12 plus 8 divided by 2, which equals 10. So the midpoint would be at 1/2, 10. Okay, then looking at 1b. For 1b, we'll do the same thing here. So let me just move this pen thing out of the way, or maybe I'll just zoom out a little bit. Here we go. So add the x's together. 4 plus 14 divided by 2. And then we have 5 plus 13 divided by 2. Both of these are going to give me 18 over 2, which equals 9, 9. So our coordinate for the midpoint of that would be 9, 9. Alright, so that's midpoint, you guys. Again, this is review. It's going to go pretty quick. Distance formula. Again, distance formula is just derived from the Pythagorean theorem, but it's the change in x squared plus the change in y squared. And then we take the square root of that answer. Okay, so just that's the review on the distance formula. And let's look at example 2. So example 2, Sharon hits a golf ball 12 feet above the hole and 3 feet to the left. So what I like to do with this is I like to create a coordinate plane. We'll say that the hole is right here at 0, 0. If she hits the ball 12 feet above the hole and 3 feet to the left, 1, 2, 3, will be at the coordinate negative 3, 12. Okay, so that's where she hit the ball. Again, the hole is right here in the center. And then it says she takes out her putter and tries to hit that thing in, and on her first putt, it traveled 2 feet above the cup and 1 foot to the right. So that coordinate would be, remember to go x first, so 1, 2. Okay, so we're trying to find the distance between those 2 points. So let's use our distance formula. All right, so it doesn't really matter what you call point 1 and point 2, but just keep it consistent throughout. Okay, so I'm going to just start with the negative 3 up here. So it'll be negative 3 minus 1 squared plus 12 minus 2 squared. When I do that, I get negative 4 squared, square root of negative 4 squared, plus 10 squared, which is the square root of 116. I guess I don't really mind if you leave it in terms of square roots here. You could simplify this a little bit more because I know that 4 goes into that, but I guess we'll just do this out here. So the square root of 116, if we want to round that, is, let me just pull that up. This is equal to 10.77. And I guess we're in feet. Okay, example 3 says the coordinates for points A and B are -4, -5, and 10, -7 respectively. It says find the distance between the midpoint of those things and point B. Okay, so the first step is to find the midpoint. The midpoint would be -4 plus 10 over 2 and -5 plus -7 over 2, which gives me 6 over 2 here and -12 over 2 here. So the midpoint would be 3 comma -6. Then I'm going to use that and find the distance between that and point B. Okay, so we take the square root here. Let's do x2. We'll make this x2, y2. So we'll have 10 minus 3 squared plus -7 minus 6. Oh, -7 minus -6, so -7 plus 6. Careful of your signs there. Squared, and then we'll do this out here. So the square root of this will be 7 squared, which is 49. -7 plus 6 is -1. -1 squared is +1. So we get the square root of 50, which they give us right here. All right, and you guys, that is it. I have given you a homework sheet, so have fun practicing your distance and midpoint formulas, and we'll see you next time.